Okay, we're in the middle of a very long problem here. So we're trying to take a look at this. We've determined that there's going to be this thing called beating, which is where I have these long sinusoidal curves, and within those curves I've got some rapid oscillations going on. And so we had determined that our solution to this was going to be the real part of this complex solution that I've written down here. So I'm now just trying to figure out what is the real part of this. So we've got the 1 over 16 minus omega squared. That can just sort of hang out for a while. That's a real number. This is cosine of alpha t plus I times sine of alpha t. This is cosine of beta t plus I times sine of beta t minus, and this will be, I'm subtracting the whole thing, minus cosine of negative beta t plus I times sine of negative beta times t. Now what I want to do here is use the fact that cosine is even and sine is odd. So what I'm going to do is distribute this negative, and I'm also going to say cosine of negative beta t is just the same as cosine of beta t. So, whoops, that was beta t, not cosine to the beta t, cosine of beta t plus I times sine of beta t minus, this is just the same as cosine of beta t, okay, minus sine of negative beta t is negative sine beta t. That negative's going to cancel this, so plus I times sine of beta t. Okay. And we're multiplying that by cosine of alpha t plus I times sine of alpha t, and by 1 over 16 minus omega squared. Now, what happens is the cosine of beta t's cancel out. So this becomes 2I sine beta t. So I've got 1 over 16 minus omega squared times cosine of alpha t plus I sine of alpha t times 2I times sine of beta t. That is 1 over 16 minus omega squared, and I can FOIL this out. So I'm going to get 2I times cosine of alpha t sine of beta t oh, I'm not foiling, I'm just distributing. Sorry, this only has one term. Okay, so I distribute that there. Minus 2 sine alpha t sine beta t. Okay. So notice it becomes minus 2 because I get that I squared, which is negative 1. Okay. So now I can see I'm going to have this distributed to each thing, but this part has an I in it, so that's the imaginary part. This part, multiplied by this, is going to give me the real part. Okay. So what we will have, I think I'm going to go ahead and factor out that negative 2. I'm going to get 1 over 16 minus omega squared times a negative 2. So I'll just put the negative 2 on top. Okay. Times sine of alpha t times sine of beta t. So I'm getting that this is a multiple of a product of these two trig functions. Now remember, alpha was omega plus 4 over 2, and beta was omega minus 4 over 2. Now, it turns out these are now the angular frequencies of these two factors in my real solution. Okay. So it turns out that these are the numbers then that are going to help me to determine the frequency of the beats and the frequency of the rapid oscillations. So here's how it works. I'm going to just list the number. I'm going to list the associated period that we would get for a trig function with that angular frequency, and I'm going to list the associated frequency. Okay. So if I have alpha is omega plus 4 over 2, the period of something like this, remember if I wanted to find the period of this, it would just be 2 pi divided by alpha. So this is going to be 2 pi divided by this, which gives me 4 pi over omega plus 4. Okay. The associated frequency, the frequency is just the reciprocal of the period, that's omega plus 4 over 4 pi. Okay. If I look at beta, which is alpha minus 4 over 2, the associated period is 2 pi divided by this, which is going to be 4 pi over omega minus 4. Now, that's actually going to have to be an absolute value because by definition a period is always positive. If this ends up being a negative number, well, then I'd say sine of beta t is just the opposite of sine of beta t, and so the absolute value of beta would be what's giving me the angular frequency and what I would use in calculating my period and frequency. Okay. So this is going to be the absolute value of omega minus 4 over 4 pi. Okay. Now, how does that help us? Okay. Well, it turns out one of these is the frequency and period for the beats. The other is going to give me the frequency for the rapid oscillations. Can't quite refer to the period of the rapid oscillations because it's not quite a periodic function because the amplitude is changing. Both of these functions have a period associated with them. The rapid oscillations are technically not periodic functions because they don't repeat exactly the same pattern because the amplitude is changing. Okay, so let's see if we can figure out which is which. Okay. So the frequency of the rapid oscillations, there are a whole lot more of them per beat, so that's got to be the bigger number. Remember, omega and 4, we're only going to have beating if omega and 4 are close. That means this is going to be a small number, this is going to be a big number. So alpha is going to give me the rapid oscillations. Beta is going to give me the beats. Okay. Let's take a look at an example where we actually choose a specific value of beta. Sorry, not beta, of omega. Okay. So we said we wanted something that's relatively close to 4. I'm going to just choose to make omega equal to 3.5. Okay. All right, so if omega is 3.5, let's just figure out what our alpha and our beta actually are. Notice that's 7/2. Okay, so then alpha would be 7/2 plus 4, which is 8/2, would be 15/2 over 2. That would be 15/4. And beta would be 7/2 minus 8/2 would be negative 1/2 over 2 would be negative 1/4. Okay. So notice beta is negative in this case, but it's the absolute value that's going to be showing up when we calculate period and associated frequency. Okay. So the period associated with this is just 4 pi divided by 15/4, which is 16 pi over 15. the period associated with this would be 4 pi divided by the absolute value of negative 1/4, which is just 16 pi. The associated frequencies then are the reciprocals, 15 over 16 pi and 1 over 16 pi. 15 rapid oscillations for 1 beat, because this frequency is 15 times bigger than this one. So we're going to have 15 rapid oscillations for every 1 beat that we have. Okay. And I know that the beats are I'll have 1 beat over an interval of like 16 pi. Beta was for the beats. Okay. So I think we're just about ready to graph this solution. Again, we've been going for a while, so I'm going to stop this video and we'll finish this problem in the next one.